Algebra with Miss Swartz. Today we're moving on. We worked on simple equations yesterday. Today we're going to take it a step further and we're going to add multi-steps. So there's going to be more than one step to solving these equations. So we're first going to define what it means to solve multi-step equations. This is in your journal and under 1.2. But it wouldn't hurt to write it down. To solve a multi-step equation, we need to simplify each side of the equation. That's the big difference between our simple equations and our multi-step. We have to simplify each side of the equation if necessary, and then we will do exactly what we were doing before by isolating the variable using inverse operations. So we have a few definitions again that we're going to look at and make sure we understand, and then we'll do some examples and we'll get you going on. So let's look at these two vocab words first. Coefficient. The coefficient, hopefully you know what that is. A coefficient is a number in front of a variable. So a number pretty much being multiplied by a variable. So it looks like this. Okay, 5x. If we have this, 5 would be our coefficient here. So the number in front of a variable. A constant, a little bit simpler. It's just a number in an expression. So, for example, if we had 5x plus 4, okay, here's an expression, not an equation. There's no equal sign. This is an expression. 5 is our coefficient. 4 is a constant here. This would be our constant. This would be our coefficient. So just a plain number. It doesn't have a variable with it. So you could say without variable. Okay, so those are important to know. Those are just kind of added vocabs I want you to know as we move forward, because we're going to talk about combining like terms. You've probably seen this last year. We're going to start with expressions, not specifically equations, because we want to practice how we would simplify each side of an equation before we go on to actually solving these equations. So combining like terms. We can only combine like terms when they have the same variable raised to the same power. So we won't really deal with much of being raised to the same power right now, but definitely the same variable. We can only combine them if they have the same variable or if they are constants. Then we can also combine them. So my example I always use here, okay, if I'm combining items such as an apple and an orange, okay, if I have one apple and 2 oranges, I would never say I have 3 oranges. One is still an apple, one is still an orange. I cannot combine them unless they're the same. Now, if I have 1 orange and 2 oranges over here in a different group, then I can combine them and say I have 3 oranges. Maybe that makes sense to you, maybe it doesn't, but if we look down at our example here for A, I have 7x minus 1 plus 2x. Okay, you can only combine things that have the same variable and are raised to the same power. Okay, or I could combine constants. In this case, I have 7x, they have the same variable, and 2x with 2x. I also have a constant of -1 here, or -1, okay? So I have to decide what are my like terms if I want to simplify this expression. Well, 7x and 2x have the same variable, and those variables are raised to the same power of, okay, 1. So 7x plus 2x, because the plus is in front of the 2, I would have 9x minus 1. Now, because 9x and 1 are not like terms, that's as far as I can go. So this is my answer. That is simplified. If you have questions on this, please ask. So for B, I have 3m plus 2 minus 6m plus 8 minus 1. When I have a lot going on, I like to make sure that I have just all addition all across the board. So I go through and I change subtraction to addition and change the sign of the next number, just so I can make sure that I'm doing everything correctly. So now my like terms, okay? I always try to underline my like terms. So I have these two as they have the same variable raised to the same power. So 3m plus negative 6m would give me negative 3m. Then I have my constants. So I have 2 plus 8, which is 10, plus negative 1, which would be 9. These are not like terms, so I cannot do anything else with them. It's as simplified as it can be. So that is how we combine like terms, simplify expressions. So now we're going to take this information and we're going to use it to help us solve equations. This first one, we're going to look at it. Do we have anything we need to simplify? Well, in this case, no, we do not. Everything's as far as it can go. I can't combine any negative 2n and 3. 9 is by itself, so I just have to solve for n. So I'm going to subtract 3 from both sides. I have negative 2n equals 6. Because this is my inverse operation, and if I do it to one side, I have to do it to the other. Okay, some people like that line down the middle to make sure they do it to both sides. You do need to show that work. Some people are struggling with the work piece. I brought everything else down, so once I got rid of this, my negative 2n came straight down, and 9 minus 3 is 6. Now I need to get n alone. Here's where that multi-step comes in. I have to do more than one step. I'm going to divide by negative 2, so n is going to equal negative 3. On a quick check, negative 2 times negative 3, if I plug this back into n plus 3, should give me 9. So this is a positive 6 plus 3 equals 9, which is true. So I want you to go ahead and try this one on your own. Now, this is a multi-step problem, so be careful, be aware of this subtraction sign and what that could mean for you. Try it on your own. If you have to pause the video, that's great. Okay, so now we get to the point where we're going to be combining some like terms. We have to make sure each side is simplified before we can go ahead and solve. So, negative 12 is all good, but on the right hand side here, I have 9x minus 6x plus 15. I can combine some like terms because 9x and 6x have the same variable and are raised to the same power. So 9x minus 6x is just 3x. And then I can bring that 15. Now I'm simplified and I'm able to solve. Subtract 15 on both sides. Careful here. This is negative 12 minus 15, or negative 12 plus negative 15. So same sign, add and keep. I would have 27. It would be negative. And then I'm going to divide by 3 on each side. So negative 9 is equal to x. If you checked that, you could plug it all back into here, or you can plug it into this one. So 3 times negative 9 plus 15 should give me negative 12. So this is negative 27 plus 15, and in fact, that does give me negative 12. Okay, so go ahead and try this one down here. Make sure you combine your like terms, and then go ahead and solve, show all your work. The last thing we're going to do is look at a story problem here. I didn't do a story problem example yesterday, so I wanted to make sure I did one today. You have 96 feet of fencing to enclose a rectangular pen for your dog. To provide sufficient running space for your dog to exercise, the pen should be 3 times as long as it is wide. It says find the dimensions of the pen. So I'm going to draw a picture. Drawing pictures is really good practice, okay? It says that the length of my pen should be 3 times as long as it is wide. So the length is going to be 3 times however much my width is. So we're going to call the width x since we don't know it, and my length 3x. So all the way around would look something like this. Now I can set up an equation. So that means I have 3x plus 3x plus x plus x would give me, well, I only have 96 feet. So 3x plus 3x is 6x. X plus x is 2x. I want to simplify that whole side so I can continue to combine my like terms. I end up with 8x equals 96. So to get x alone, I'm going to divide by 8 on both sides. X would equal 12 feet. Okay, well that tells me the width. What about the length? To get the length, I would have to take 12 times 3, which would give me 36. So my dimensions would be 36 by 12. Okay, if you've completed this, here's your homework listed right here. I do still want to look at your notes, so make sure you talk to me. And then if you have any questions, you can ask them then. All right, have a great day.